Hello everyone. Okay. Hello everyone. Welcome to today's live session on Object Lifetime in C Sharp. I am Raity and this is my sixth live presentation and I'm excited to share this topic with you. First, we will start with the basic idea of Object Lifetime, what it means and why you should care. Then we will talk about the garbage collector, the system that cleans up objects for us. And we will also explore concepts like the stack versus heap, strong and weak references, and more advanced ideas like a small object heap and large object heap and generations. By the end of this session, you will have a strong understanding of how C# manages memory, and you will be able to answer questions like why do some objects live longer than others, and how can we ensure objects are properly cleaned up, and what can we do to avoid memory leaks in our programs. And my goal today is to make this topic as simple and practical as possible. I know concepts like garbage collection and memory management can feel abstract, but I hope you leave this meeting with clarity. And so let's start. What is object lifetime? Let's start with the first topic. To understand this, think about a person's life. A person's life starts when they are born and ends when they pass away. In C Sharp, an object's lifetime works in similar way. The moment we create an object using the new keyword, the object is born and it starts its life. While the program is running, we might use that object, modify it, or reference it. But when the program no longer needs it, or if there are no references pointing to it, the object dies. Okay, imagine you create a toy and place it on a table. As long as the toy is on table, it's accessible. But if you throw it into a river and walk away, you can get it back. The toy is lost. In C Sharp, when we lose the reference to an object, it becomes unreachable. And at this point, the garbage collector will come along and clean it up for us. To summarize, an object's life starts when you create it with new, and it continues living as long as there are references to it. And when there are no references left, its lifetime ends and the garbage collector cleans it up. This concept is important because managing objects properly ensures your app doesn't waste memory or run out of space to create new objects. Now let's talk about a very helpful system in C Sharp, the garbage collector. Imagine you have a robot assistant at home and you don't have to tell it to clean up. It just knows when to throw away all old newspapers, empty bottles, and trash. The garbage collector does the same thing for our app. And whenever you create objects in your program, C Sharp stores them in memory. But if those objects are no longer needed, they still sit there, taking up space. Instead of asking the programmer to manually delete them, the garbage collector does it for us. Why is this helpful? The first reason is it's automatic cleanup. It means you don't have to manually free memory like in C or C++. The second reason is because of its prevents memory leaks. If we forget to release unused objects, they take up memory. And the last reason is because of its better performance. It optimizes memory usage, which makes our app faster. The garbage collector doesn't run all the time. It waits for the right moment, like when memory is getting full or when your program has free time. The garbage collector checks which objects are still in use and which are not. And if an object is no longer used, it's removed. So, in summary, the garbage collector is like a background cleaning robot that ensures your app doesn't run out of memory by cleaning up dead objects that are no longer in use. Let's go to next page and let's discuss the difference between stack and heap memory. Imagine a small desk and a big storage closet. The stack is like the desk. It's small, fast, and used for quick tasks. And the heap is like the closet. It's bigger, slower, and stores larger items. When you create simple data like numbers or booleans, C# stores them on the stack because they are small and temporary. But when you create larger objects like arrays or objects with new, they go on heap. And look at this example. Here, if we declare an int variable, the number 10 goes on the stack. But if you create an object, the object is stored in the heap and a reference to it is placed on the stack. The stack is fast and clears itself when the method finishes. The heap requires the garbage collector to clean it up. And if I want to summarize all these concepts, a stack is small, fast, temporary storage for simple data, and heap is larger, slower, and used for objects and reference types. It's important to understand this because managing memory efficiently makes your app run faster. Let's move on to a strong versus weak references. Imagine you have a balloon tied tightly to your hand with a string. No matter where you go, the balloon stay with you. This is a strong reference. The balloon, I mean object, cannot fly away. I mean be garbage collected. Now imagine you hold the balloon with a loose grip. If the wind blows, it might fly away. This is a weak reference. The garbage collector can clean up the object if it's no longer in use. But why do we need this? If you have an app that shows images, you don't want to keep every image in memory. A weak reference lets the image stay in memory only as long as it's being used. And if memory is low, the garbage collector releases it. So if the object stays alive as long as there is a reference to it, that reference is strong. But if the object can be garbage collected, even if a weak reference exists, that reference is weak. Uh, okay, now let's see how the garbage collector actually works. The process can be broken into three simple steps. The first step is mark, and it identifies which objects are still in use. And the second step is sweep. It removes objects that are no longer in use. And the last step is compact, that it moves remaining objects to avoid fragmentation. So about this scenario, imagine you have a row of chairs. People sit on the chairs, I mean objects, and when someone leaves, there is an empty chair. The garbage collector marks which chairs are empty, and it was about the first step, I mean mark, and removes the empty chairs. It's the second step that was sweep, and then moves the people closer together. It was the last step that was compact, so there are no gaps anymore. The most important concept here is reachability. If an object can be reached by the program, it stays alive, and if not, the garbage collector collects it. So this process helps keep memory organized and clean so your app can run faster. The garbage collector organizes objects into two categories. The first one is a small object heap, and it's for small objects less than 85 kilobyte. And the second one is a large object heap, and it's for large objects more than 85 kilobyte. And what is the difference here? Smaller objects are easier to move and clean, so they go into a small object heap. And larger objects like images or big arrays go into large object heap because moving them around would be slow and inefficient. Uh, about its example, think of a small object heap as a drawer for small items and the large object heap as a big storage room for larger items. Its structure helps the garbage collector be more efficient in cleaning up memory. Let's go to another page. Okay, to optimize memory cleanup, the garbage collector uses three generations. The first one is generation 0, and it's for new objects, and the second one is generation 1 for objects that survive one garbage collection, and the third one is generation 2 for long-term objects that stay in memory. New objects start in generation 0. If they survive the first cleanup, they move to generation 1, and if they continue to survive, they are moved to generation 2. But why do we use this? If you think about garbage at home, you might throw away food scraps every day. It's like generation 0. And you throw out recycling every week. It's like generation 1. And you throw away big old, for example, furniture only a few times in your life. It's like generation 2. And this strategy ensures that objects that live a long time, like application configuration settings, it don't get checked as often as short-lived objects, and this makes garbage collection more efficient. Let's start with two important concepts, finalizer and IDisposable. A finalizer is a method that runs automatically when the garbage collector removes an object from memory. It gives us one last chance to clean up unmanaged resources like open files or network connections. But here is the catch: you don't know exactly when the finalizer will run. It runs only when the garbage collector decides to collect the object, and this could happen later after than you expect. About this part, imagine you open a file and you forget to close it. If you rely on the finalizer, the file might stay open for a long time, which could cause errors. And when the program ends, the finalizer will run and you will see finalizer is running in the console. But remember, we have no control over when exactly this happens. But about disposable, this is the better option. Because with IDisposable, we don't wait for the garbage collector. We clean up resources manually by calling a method that called dispose. And think of it like this. For example, imagine you borrow a book from a friend. If you wait for the friend to come and collect it, it might take a while. And that's like the finalizer. But if you return the book yourself, it happens faster, and that's IDisposable. And here we have some examples. And here we are taking control of the cleanup by calling dispose directly, and if possible always use IDisposable because you control when cleanup happens, and avoid relying on a finalizer because they are slow and unpredictable. Let's look at the using statement. For example, if you open a file, write some data, and then forget to close it. If you forget to close it, the file stays locked and no one else can use it. The using statement makes sure the file is closed automatically, and the using statement works with objects that implement the IDisposable interface. This means that instead of calling dispose manually, using does it for you when the code inside the block finishes. Here, let me show you an example. Here in the first code, we open a file called log.txt and we write hello world inside this method and inside of this block, sorry. When the using block ends, the file is automatically closed and no need to call dispose. Without using, you would have to write like the second code, I mean this part. And you have to call dispose yourself, and if you forget, the file stays open. But with using, cleanup happens automatically. And using when you work with files, streams, and database connections because it's safer, cleaner, and avoids memory leaks. Now we are moving to another important concept in C#, boxing and unboxing. To make it simple, let me ask you this. Have you ever tried to put a small item, for example, like a phone inside the box, and later you take it out of the box? Putting the phone into the box is boxing, and taking the phone out of the box is unboxing. Now let's see how it works in C#. When we convert a value type like int, double, or another types into an object type, this is called boxing. And here is a quick example. We have an integer number. We store this integer inside an object called box number. And since objects are stored in a special part of memory called the heap, this conversion process is called boxing. Why does C# do this? Sometimes we need to store value types in a structure that only accept objects. For example, like connections and the array list, or methods that require object as a parameter. So what about unboxing? Here is how it works. We have an object that holds the number 42. We cast it back to an int using int box number. And what's the problem with boxing and unboxing? It's really slow, and every time we box, the system creates a new object on the heap, which takes time and memory. This can hurt performance if it happens a lot. So how we can avoid it? We can use generics instead of boxing. For example, instead of using an array list, which uses objects, use a list of integer. So with this, avoids boxing because list of integers directly holds integers. So thank you so much for being here today. I hope you find this session helpful, and thanks again for your time, and I look forward to seeing you in my next presentation. Have a great day. Goodbye all.